giving a presentation on wearable devices. In this presentation, I will explain the basic concept, component, applications, advantages and future scope of wearable system. Now let us begin with an introduction to wearable system. Wearable system and introduction. First let us understand what a wearable system is. Wearable systems are electronic system on the human body for continuous monitoring. They use sensor, process and wireless communications. Examples include smart watches and smart clothing. Wearable system. There are essentially autonomous non-invasive systems that integrate sensor, process, conversions of BME, microelectronics and IoT, design of ambulatory monitoring, support real-time biofeedback to the user. Now let us move the next slide. The need for wearable system. Now let us discuss the need for wearable systems. Aging population, chronic diseases, cost efficiency. Aging population means global rising elderly citizens requires remote care solutions to reduce the burden on assisted living facilities. Chronic diseases is managing conditions like CVD and diabetes requires 24/7 observation, prevent acute episodes. Cost efficiencies in preventive monitoring, reduced expensive emergency ER visit and long-term hospital stays. Now let us move the next slide. Visual. Now let us look at the visual comparisons of wearable sensors and traditional safety equipment. Wearable sensors and function monitors and alert to prevent risk. Traditional safety is reduce harm during incident. Connectivity. Wearable sensor wireless. Connectivity, traditional safety here none. The battery power, wearable sensor is high, no power needed. Limited, wearable sensors is the physical protection limited. Safety high, real time continuous streaming, data transmission, no data generations. Now let us look at the applications of wearable system. First one is remote health, sports science, occupational. Home-based remote health means home-based cardiac monitoring and post-surgery recovering tracking. Sports science, elite gait analysis and musical fatigue monitoring to optimize athlete performance. Occupational monitoring firefighter vital and fatigue levels in long-haul truck drives. System architecture core component. Next, now let us move the next slide. Classification of wearable system. First, wrist one, second one is head one, third one is body one in shoe. Which one the most common form using PPG and IMUS? Head ones EEG headband and smart glasses for cognitive load for neurofeedback. Body one, chest strap for ECG rip or skin patches for biochemical sensing. In shoe, pressure sensitive involves for gait and ground reaction for analysis. Next one is detail focused textiles. Electronic textiles. Detail focused textiles means electronic textiles. The concept of the electronic textiles integrate. Now let us look at the e-textiles. Integrate electronic component directly into fabrics. This removes the device feeling and makes monitoring truly seamless. The main requirement is durability because the textiles should withstand washing and stretching. Conductive fiber, silver, carbon, coated threads woven into standard cotton plaster. Tray electronics. Next let's move at tray electronics, fabric based electrode that to recure conductive gels for ECG sensing. Durability. The durability must withstand 100 washing cycle and extreme physical stretching. Now let's say the core component of wearable system. There are three important components of processing connectivity power. First, processing is done using low power microcontrollers for signal processing. Second, connectivity is provided by Bluetooth low energy PLE for wireless data transmissions. Finally, power is supplied by thin film batteries or energy harvesting methods. These three components work together that made the wearable system efficient and portable. Now let us move the next slide. This is diagram shows the data wearable system. Let us move indoors monitoring equipment, location detection. First is indoors, second location detection, third is cloud server database, fourth is monitoring equipment. Typical wearable body area network hardware stack. Now let us next slide. Sensor the bio-digital interface. Sensor are the most critical component of responsible for converting physiological variables into measurable electrical signals. They must be flexible, biocompatible and stable over time. Wearable sensor key categories: biomechanical accelerometer, cryos pressure, biopotential ECG, EMG, EEG, environmental temperature, humidity, gas, biochemical, glucose, sweet lawn sensors. Sensor biological in a wearable sensor, machine learning, smart materials. Then now let us next slide. Interior geoscope magnetometers. Gyroscope measure angular velocity, essential for tracking complex rotation of limbs during gait or athletic maneuvers. Detect the magnetometers detect the earth magnetic field, provide absolute healing, helping correct geodrift over time. Now let us move the next slide. Now let us move the next slide. Respiration activity sensor. Respiration activity sensor means continuous respiratory monitoring is visual for detecting apnea, asthma attack and emotional stress. Wearable methods focus on measuring the mechanical expansions of the thorax. Measurement parameters: respirator rate. Measurement parameters: respirator rate, tidal volume and minute ventilations. Challenges: motion artifact, form factor usually integrated into chest fans or smart shaft. Now let us move the next topic. Benomography, strain and pressure. Piezoresistive strain gauges, piezoelectric belts. Piezoresistive strain gauges, this conductive strip whose resistance change when structured by the step, simple cheapened but prone reef. Piezoelectric belt means generate voltage signal when compressed, extremely sensitive to honest breathing cycle but lacks absolute volume accuracy. Now let us move the next topic. Ground reaction force sensor. Ground reaction force GRF sensor. GRF sensors measure the forces exerted by the ground on the foot. This data is visual for orthopedics and sport performance. First, smart insoles, array of thin film pressure sensor, FSR force sensing register. Parameters: heel shake timing, center of pressure and impact magnitude. Importance means detecting abnormal gait cycle in Parkinson or rehabilitating post-ACL surgery. Now let us move the next slide. We will discuss this more details, signal processing and energy harvesting of wearable systems. Let us understand this topic. Wearability, physical shape. The physical shape of a sensor is foundational cardinal in wearable design. Traditional electronics, right, banal, human, soft, elastic, multi-curvinable. Sensor placement optimization. Placement is determined the trade-off between physiological signal SNR and user compliance. A perfectly accurate sensor is usually refused the specific anomatically site. Sensor placement optimization. First one is chest, wrist, hair, head. Chest is ideal for ECG and respirations, provide the highest SNR due to proximity vital organs but suffer local social expansions. Which is most common of PPG and motion, high compliance but prone extreme motion artifact and signal drops during activity. Airhead, perfect for core temperature and EEG, provides stable signal but requires complex ergonomic stabilizations. Let us understand the challenges in sensor design. Designing sensor 24/7 use introduced electrode stability issues. Try electrode, avoid gel, introduce irritation but face high skin contact impedance. Material innovation, stretchable conductors, silver nanovoids, liquid metal interconnections. Biocompatibilities, ensuring materials do not cause dermatitis in inflammatory responses over 500 hours of continuous use. Current research focus self-morbiding circuit that dynamically cultivated based on movement. Let us understand this on comparative sensing. Comparative sensing wearable sensors, intelligent data acquisitions and applications. CS allows for the acquisition for signal, sub-negative restrictional sparse zero sum mathematicals. This significantly reduces ADS power and wireless bandwidth. Application ECG compression, capturing peaks while sampling sparsely during the QoS interval. Data transmissions, sending only the surprising part of signal to the cloud. Let us understand this rejection and relevant info. The primary goal of signal processing is rejection and pad patterns. That includes noise, electromagnetic interference. The rejection of irrelevant info means adaptive filtering, thresholding, HMMs classifying. Adaptive filtering means utilizing LMS, least means squash algorithm to subtract noise signatures from secondary sensors. Thresholding, implementing simulated score constraint to classify pattern as relevant signal of rejectable noise. HMM classification, hidden Markov models analysis label sequence to separate physiological event from ambient vibration data. Let us move the next slide. System power requirements means power requirements are hard killing. The wearable functionality, most devices operate a 12 volt microvolt and range to avoid thermal discomfort for the user. Typical purchase. The move of forward energy scavenging aims close to gap between battery capacity and perpetual life fashion. A successful system must harvest 100 microvolt first by being fully autonomous. Let us understand this topic, solar cell energy harvesting. Now, photovoltaic harvesting is most mature tech. Direct sunlight provides lighting else. Wearable integrations, flexible organic solar cell woven into touches, transparent PV layers integrated into smart watches, crystal glass. Curdle the slave problem. Most wearable are covered by clothing, requiring intelligent storage buffer. Next, let us move the next slide is vibration based harvesting. Understand the important topic. Vibration based harvesting means kinetic energy from human movement can be captured using three primary transduction mechanisms. First one is piezoelectric, electrostatic, triboelectric. Piezoelectric means material generate voltage and when mechanically deformed, ideal for footwear or joint integrated sensor. Electrostatic variable capacitance system that generate current as distance between plates changes, highly minimizable in MEMS. Triboelectric means generating charging through function contact between dissimilar materials. Now let us look at the next important concept, thermal energy Seebeck effect. The principle of select effect, the temperature difference across dissimilar conductor absorbs voltage. Thermoelectric generator explodes the Seebeck effect where the temperature gradient across a semiconductor junctions produced a voltage. Critical sensor factor. The efficiency is dependent on the currently gold standard for wearable systems. Thermal energy harvesting, the Seebeck effect, thermoelectricity. The mechanism is temperature difference gases or carriers from Seebeck voltage. The applications waste heat recovery in vehicle exhaust system, converting thermal energy directly useful electrical energy to power electronics to charges battery. Next, now let us discuss the more detail. Body, the 100 watt source, the human body dissipates approximately 100 watts of heat and rest. Harvesting even 1% of this cold power every sensor on a wireless body area network. Thermal impedance matching, the maximum power, the harvested thermal resistance must match the body internal thermal resistance. Let us move on the next slide. Thermopiles microtags. The thermopiles is an electronic device made of several thermocouples connected in series, while a single junction provide one. Stacking allows usable outputs. Series connection boosts voltage, parallel connection lower internal resistance boosting current. Case studies of, now let us move on the next slide. Case studies of EEG acquisition. EEG acquisition from patient to data, single pathway data transmissions, digital signal processing. Electrode placement, single pathway electrode placement. Next, lead wires cable, ECG acquisition unit transfer, the signal condition amplification, acquisition conversion. Next, data transmission. Next, digital signal processing. Digital signal processing, sampling rate, sampling resolution, digital filter, convert the filtering reduction data, notch, band pass, filter frequency, muscles, noise. Let us move on. Next slide. PPG, the motion problem. Photoplasmography measures volume changes, flood visual light. It is notoriously sensitive to ambient light and mechanical cap changes. Solutions: dual LED wavelength cancellation and simulation acceleration emits motion signature from the optical pulses signals. The next topic is AI based diagnosis, and we discuss the important topic. AI based diagnosis, modern wearable device low power machines landing on the edge. Neural network can land to the signature. The walking gait and land to ignore those specific vibrations are artifact. Benefit significant reductions in falls, positive fall detections and diagnosis error. Let us move on next slide. Most important concept, energy from smart exercise. Energy from smart exercise harvesting from energy from smart exercise harvesting from on the move energy harvesting mechanisms. Piezoelectric fiber. Second one is 320 nanometer thermoplastic electricity. Energy storage management, energy consumptions. Convert kinetic friction between fabric layers into electrical source. This allows the entire jacket, slave and energy sources. Current fabric energy consumption, smartwatches, laser transistors, LED integrated data transistors. Next, thermal comfort limit. Technical challenges often overloaded is user sensation. If you extract too much heat, it creates a cold spot sensation. Often active sensor get too warm to risk skin burn. Safety gap. Standard ISO limiter short the wearable surface must exceed 43 degrees Celsius for prolonged contact. Let us move on the next slide. Communication, the power sinks. The transmitting data wirelessly to 100x more expensive than local computations. Processing signals on devices and only inside is crucial. The communication power single means raw date. First one is raw date, second future extraction, label generation. Raw date in high battery drain. Future extraction in extracting means it locally 80% energy saving. Label generation, transmitting characters for HMM 95% energy saving. Now let us important concept. Moving the next topic. Now we will discuss the more detail. Smart exercise engineering. Smart exercise engineering means smart exercise engineering. Introduction to smart exercise. This diagram shows data from overview of smart exercise integrations. Smart exercise means is also known as electronic exercise. Smart exercise means is also known as electronic exercise. Represent revolutionary classes material capable of sensing and responding to environmental stimuli or internal physiological changes. Unlike traditional command, smart exercise integrates functional components like sensor, accurate power sources into the fabric structure. Conductive fibers. Overview smart exercise integration. The conductive fiber and sensor integration, actuator, heat exercise, microcontroller and power, data transmission, connectivity, user interface and applications. The primary engineering goal is maintain instinct exercise properties, flexibility, breathability and comfort while enabling advancing computational functionality. This multidisciplinary field levers advancement in nanotechnology, polymer science and microelectronics. Introductions of smart exercise means there are two types: active, passive smart exercise, active smart exercise. Now let us will discuss the passive smart exercise. Passive smart exercise are the first level intelligent fabric. They act solely as sensor, detecting external stimuli but lacking the ability to respond to accurate in the significant physical way. This is materials typically utilizes a physical coating. Intrinsic material properties changes. Key examples include thermochromic fabrics. Key examples of thermochromic fabric: UV productive textures, conductive interfaces. Thermographic fabrics change color based on temperature fluctuation. UV productivity tells fabric with embedded sensor that detect radiation intensity. Conductive interfaces, textile-based touchpad or strain sensor that matter. Technical characteristics. This is characteristics one-way interaction. The material collect data and transmission on the external processor of interface, but the textile structure remain static. Next one is active smart textiles. Active smart textiles accurate response system. Smart polymer actuators, soft fluidic accurate sensing, safe memory alloy integrations. System response mechanism. Active smart textiles means represent the second level of intelligence. These textiles integrate both sensor and actuator. They can environmental stimulus initiate physical response automatically. The feedback loop decentralized within garment. For example, phase change material absorb or release relevant heat to maintain to constant microclimate in temperature. The safe memory polymers alter their process thickness based on moisture or heat to increase breathability during exercise. Hydrophilic switching. Textiles that alter surface energy to repel or weak moisture and demand. The active smart textiles means smart polymer actuator, safe memory alloy integration, soft folding actuator sensing, active sensing system responses mechanisms. Next, let us discuss the detail. Next topic, conductivity fiber. Conductivity fiber means there are building blocks of e-textiles. Conductivity fiber means building blocks of e-textiles. There are generally categories to two groups: metallic monofilament and conductive polymers. Metallic monofilament and conductive polymers. Metallic fibers ultra low resistance but are brittle and lack the haptic component of traditional cotton or polyester. In contrast, conductive polymers and flexible but suffer the lower conductivity and environmental degradation. Manufacturer's method: melt spinning. Integration conductive fibers into the polymer melt during extractions. Electrospinning, producing ultrafine conductive nanofiber for surface area. Next, treated conductive fiber. Treated conductive fiber. Next topic is treated conductive fiber means traditional textile yarns, nylon, cotton, they have been modified the surface coating, chemical plating. Treated conductive fiber means traditional textile yarn, nylon, cotton examples that have been modified surface coating and chemical plating. These methods observe the original textile softness while adding electrical functionality. Common technique includes electroless planting, depositing in thin layer of silver, nickel into the fiber surface via chemical reductions. This ensures the uniform coverage. Sputter coating. The sputter coating means using physical vapor depositions caught fibers in conductive atoms, using conductive dyed graphene carbon particles. Now let us next topic, conductivity fabrics. Conductivity fabrics are created by integrating conductivity yarn fabric texture using standard textiles manufacturing process. It allows for creation of large area sensor like pressure mat or heating elements. Conductivity fibering, waving. First one is waving, knitting, non-woven. Waving means conductive yarns are used to wrap or welt, create 2D grid, ideal for stable non-structured electrical pulses. Knitting loop of conductivity thread create a stretchable circuit essentially for garments requiring high skill. Non-woven, randomly oriented conductivity fiber bonded together, used primarily for disposable medical sensor of sliding. This is conductive fabrics. Next topic is conductive inks. Conductive inks allows for the direct printing of circuit instant finished garment. This is ink consists of a conductive filler, silver, graminy, harpoon, and textile finder. The printing approach is highly scalable of cost effective. However, its ink must withstand repeated elongation and washing cycles without the conductive network cracking. Screening printing for high viscosity paste and thick circuit. In textures printing for high resolution customized pattern substrates. Now let us move on the next slide. Technical comparisons of matrix methods. Metal fibers conductivity extreme, comfort low, scalability moderate, durability moderate. Methods treated anode conductivity high, comfort high, scalability high, durability high. Conductivity moderate, comfort moderate, scalability high, durability low or moderate. Selection depends heavily on the application. Oil, ECG, electrolyte require high precision. Power links require low resistance. Metallic filament. Now we will discuss the next topic: integrated ECG monitoring. In electrocardiography, ECG, we are textile element need for irritating achieve alcohol hydroxyl electrolyte. In smart textiles, conductivity fabric patches serve dry electrolytes positioned close to the heart. The electrolytes means capture or biopotential difference across the skin. The signal is through conductivity threads to minimize the data logger to wireless transmitter. Clinical requirement. The textiles must provide consistent comparison to minimize motion artifact offset the electrode displacement during movement. Next topic is textiles electrode engineering. Traditional tri-electrode suffer from high skin electrode contact impedance to optimize signal quality in smart textiles. Medical choices, surface geography, moisture management. Decision shift. The piezo-resistivity layer can monitor the pressure applied by the garment, allowing the compensate to signal noise dynamically. Next, monitoring respiration. Monitoring respiration means respiration monitoring, workflow, breathing monitoring, chest stop, step on, wear chest stop, sense the physiological signal, data transmission, algorithm processing, display breathing rate. The vibration monitored is respirating inductive thermoscopy, piezo-resistive strain catching as they expand during initiation the texture structure. The conductivity path of fabric electrical resistance is proportional electrogram. Periodic changes the map to calculate breathing rate tidal value. Next topic is piezo-resistivity in textiles. Physical phenomena. First one is geometric change, contact change, percolation shift. Next, data acquisition and noise. The raw signals are smart textiles in noisy noise due to the electromagnetic interference, musical noise. The data acquisition system include instrument amplifier, digital notch filter, adaptive filter. The wireless cup signals are typically processed by a tiny POD clip to the shat, which transmit data via Bluetooth low energy of mobile applications. Technical and practical challenges: washability, connectivity, power supply. Washability, conductivity, coating often take off after repeated laundry cycles, encapsulations. Connectivity, Connectivity, the hard soft interface connecting right electronic chips to staff connectivity. Power supply requirement need lightweight, flexible battery, energy harvestings. Now let us understanding the remote health applications. Remote patient monitoring, the smart government workflow. Smart exercise enables long-term ambulatory monitoring, chronic persistence, chronic heart features, ECG integrated, undershock detection. The article before is late stroke. Step 1, wearable sensor badges. Step 2, meal logging, nutrition. Step 3, cloud data area analysis. Step 4, healthcare data dashboard. Step 5, patient feedback loop. This is application, remote health applications. Athletic training. In high performance sports, respiration and ECG monitoring are used to calculate V02 max and fatigue index. Load monitoring, fire feedback, telemetry. Next, let us move off the next slide. Interconnect technologies. The biggest point to features. Textiles connected soft fabric, rigid electronics. Modern solution include connectivity, expose, snap, fastest, magnetic clothings. Now let us discuss the more detail. Next topic, diagnosis from episodic to continuous. Medical diagnosis, traditional, relay, clinical wearable diseases. AA system processing wearable data, predict acute kidney injury, 40 hours, 8 hours, 90% accuracy in serve cases milestone for critical care diagnosis. Next, the continuous monitoring framework. The continuous monitoring framework means medical monitoring before diagnosis for focusing long-term surveillance, known as conditions. Remote patient monitoring saved the healthcare system estimated $200 billion by preventing emergency equations. Next, metabolic autonomic diabetes care. Diabetes care management has been pioneered in revolution. Continuous glucose monitor largely replaced the finger prick methods. The 30 million patients globally, CGM system allows for much triglycemic control slightment. The modern system fed data into insulin pumps create artificial princesses. Cardiovascular autonomic heart failure. The next topic is more important. Cardiovascular automatic heart failure. Heat failure management via wearable focus registering, impedance, white difference, heart rate pattern, clinical and intervention before full down risk. Key HF sensor, impedance sensor, track pulmonary contraction, accelerator, monitor acceleration base, diaphragm. The smart node connected inpatient, the in-hospital involving the reduce the workload nursing staff, improving the patient safety. The manual check 4 hours, build fort where the patient electrolytes in 15 hours saved ward day. Dashboard nursing savage visualization, 30 patients immediately highlights the detections. Trends warning the through the color code alerters. Bed 2 means nursing calling system, nursing dashboard, mobile calling unit, additional services. Next, let us move the next slide. Pediatric audience aging in place. For the elderly, wearable health autonomous ability live independently at home, aging place in constant upon the responsibility. Beyond emergency, the benefit tracking, activity of daily living, the changes bathroom is frequency, sleep duration to gauge speed, signal continuity, physical baseline on long before the crisis, accuracy, identifying dangers, faults, specific losses in resistance models. Next topic is combating isolation and practicality. Practicality assessment, quantitative surveillance, social connectivity. Next, neural recording, the PCO printer. Wearable neural recording primarily utilizes electroballonography that captures electrical activity from the brain. High density wearable EEG headset allow long-term monitoring outside the brain computer interface. BCI means the signal allow patient with servo motor impairment to control prosthetic limbs communication software through patterns. Application range from clinical diagnosis, performance enhancement, high stress proportionals. Next topic is ellipse management, sexual predictions. The accuracy section predictions analyzes heart rate pattern via ML models, sexual locking, nighttime safety, VN tracking. Next topic sleep charging and clinical neuro health. Sleep is the neuro repair phases human body. Wearable breakdown the motion analysis, sleep disorder and the early indicator system metabolic. For Parkinson's and discharging track, trumpet signatures on off medicine cycles. This is ensure the medicines is precise time and patient symptoms begin to recur. Clinical value of sleep data, constitutive recovery, collected in deep sleep with daily continuity scores. The stress impact monitoring nighttime HR spikes in the high sign or chronic overactions. Gait analysis walking signature. The random forced classifier train wearable gait signatures, then classify failure, non-failure with 98 accuracy. Key parameters include stride length, corner step and pressure distributions. Next one is orthopedic rehabilitation mapping. Orthopedic rehabilitation post-surgical rehabilitations require objective evidence improvement. Loading symmetry, range of motion, recovery milestone. Loading symmetry ensure the patient not favoring the one leg with least compensating strain secondary injuries. Quantifying the practice the dynamic movement in daily life. Recovery milestone, the benchmarking gain speed against aging, the stroke service IMU sensor vs lab trade equipment. The primary technology challenge matching accuracy expensive. The 24 monitoring function and search environment like the facial comb. Current sensor fusion algorithm can resolve joint until 2-3 degree lab grade standard. Next, sport medicine performance front sensor. We will discuss the more detail. Important elite sports medicine uses wearable suits and physiological load into competitive advantages. Heart rate recovery and mutual oxygen coaches the ensure port GPS and high accelerations converted into forward momentum. This managing internal the external load, the external load, injury prevention, high accuracy workloaded wearable allows to quantity to strain athletic standard in real time, differentiating between the work down, the external load, the body response, internal load. Cardiovascular load, monitoring the time spent, high intensity HR zones, the prevent cardiac strain and the fatigue related mechanical loaded. Tracking G poses during impact or jump to managing muscular stress and concert ports. Fatigue directions decrease the jump height and stretch, can signal nuclear fatigue before soft tissues, encouraging accuracy. Next, visualizing biomechanical strength, athletic performance optimization workflow, athletic innovation, data collections, training and performance training, routine monitoring. Fourth one is optimize performance progress, athletic support innovation. Key performance of indicator, heart rate variability, training load, sleeping quality, product output, hydronutrients means. By comparing instrument, healthy limb biomechanics, therapeutics and quantity, athlete pre-injury semester loading capacity. The digital, now let us discuss the next topic, the digital bridge telemedicine. Comparison telemedicine workflow, patient to provider journey. Patient 1, patient indications, visual visit data flow, routine monitoring for clinical investigation, flow of care. Phase 1, patient investigation, patient experience symptoms, video communication with the doctor, routine monitoring, normal data recorded, automatic follow-up, care plan continued. Clinical intervention, doctor review, nurse, flow of care, medication, care plan update, patient notification, flow of technical advantages of micro, global standard, lower interface and reliability, ultra low power. The integrations facilities provided, health coaching via AA news based on wearable data, health patient manage the diet and activity romance, activity daily. User health official detect emergency disease cultures. Remote monitoring dashboard consolidated data from million users, help of public health official. Next, ethics in high density health data. The accumulations for 4,000 biological data point introduced significant preventive risk. Who want the data? How is protected? The insurance employer. Ethical consideration must keep on technological advancement. Encryptions, anonymizations, data sovereignty, end-to-end encryptions from the wearable nodes. Monitoring the creating will mining. Patient must have right data, their biological, corporate and clinical databases. Next one is the calculate wearable devices summary impact of wearable system. Wearable system represent the single most impactable transition is 21st century medicines. By moving from episodic to continuous care, we are solving the most expensive problem in healthcare, late diagnosis and chronic mismanagement. He impact area summarize cost 60% reduction in hospital expenditure through remote oversight. Safety 43% reduction in cardiac readmission, 98% fall detection accuracy. Longitudinal tighter glycemic control and predictive neurocare. The final insight, the ultimate goal of wearable technology is to become invisible, disappearing into the background of a patient life while acting as a 24/7 medical guardian. As AI models become more sophisticated, the system is transition monitoring health to activity predicting and preventing diseases before is accurate. To conclude, wearable devices play important role in modern healthcare. They enable continuous monitoring, real-time data collections, and better patient care. Thank you for attention. Thank you.